Okay, so we are going to actually we are learning signal conversion device. Okay, mainly analog to digital conversion and digital to analog conversion. Okay, so these devices we need to discuss further. Okay, so I think now you can remember maybe. Okay, we have discussed 4 type of signal. That is important. Okay, so you need to know that one: analog signal, digital signal, okay, and continuous time signal, discrete time signal. So I have explained this in previous week. Okay, so analog and digital we categorize based on the amplitude levels. Okay, based on the amplitudes level. Okay. So analog signal means if infinite, that means uncountable. Okay, uncountable amplitudes levels are there. Okay, levels are there. That is called analog signal. And if finite, that means countable amplitudes is there. Okay, amplitudes levels are there. We called it digital signal. Okay, digital signal. For example, analog signal is like this. Okay, so if you get to point, okay, so you have infinite number of signal, this amplitudes level. Okay, so digital signal, it is just like this one. Okay, this kind of signal. Okay, so you can see that this is called actually staircase signal. Okay, so it has a number of finite amplitudes level. Okay, so you can count the amplitudes level. Okay, and continuous time and discrete times we categorize based on the time. Okay, so here the amplitude level based on amplitude levels. This is time points. Okay, this is based on the time axis. This is amplitude axis. Okay, analog. Okay, so if the time is continuous variable, continuous means between 2 points you have infinite number of time points, okay, so that is a continuous variable. Okay, infinite number of time points. Okay, time points. So it is a continuous time signal, and if the time is discrete, time value is discrete, that means time has time value, we have countable time points. If we have countable time points, okay, time points or finite time points, those are discrete time signal. For example, continuous time signal is like this. Okay, so actually analog signal is a continuous time signal. Okay, analog signal is a continuous time signal in nature. Okay, and discrete time, but analog and the definition is different. Okay, the continuous time means based on the time axis, and analog means based on the amplitude axis. Okay, and discrete time signal is somewhat like this. Okay, this kind of signals are discrete. Okay. So this is time, and you can count the time point. Okay, so this is continuous time signal, and this is discrete time signal. Okay. Okay, so that is the things. So this you should be familiar with these 4 type of signals, 4 category of signals. Okay, and so in electronics, okay, in digital system, we like to use, so digital signal may be few amplitudes level. Okay, that means maybe 5 amplitudes level, 6 amplitudes level, like that. Okay, but we like to have 2 amplitudes level. It is easy for the processing. Okay, so normally in electronic system, okay, digital signal has only 2 amplitudes level. Okay, that may be high amplitude level and low amplitude level. Okay, So sometimes high is represented using 0 or 1, and low is represented with vice versa, 1 and 0. So on. Okay. Like this. Okay. So that idea you should have. Okay. So then we will see what is so. Okay. So if you consider ADC, analog to digital conversion, analog to digital conversion. Okay. So the task of that, okay, if you give an analog signal here, okay, you will have a discrete signal. Sorry, the digital signal. Okay, so analog signal may be like this. Okay, then you have a digital signal. Okay, and in electronics we like to have two levels digital signals. Okay, so you will have this kind of digital signal. Okay, it will have only two levels, two amplitudes level. Okay, clear? I think now you should be familiar with these things. Okay, so that is the function of the ADC. It converts analog signal into digital signal. Analog into digital. Okay, and DAC, DAC. Okay, so if you have the DAC, okay, if you given digital signal like this, okay, digital signal like this, you will have an analog signal. Fine, like this. Okay, so this will be the digital signal, and the output will be the analog signal of the DAC, DAC. Okay. So it convert digital signal into analog. Okay. So anyone can tell me why we need these circuits? Can you answer that question? Why we need this ADC and DAC? Can anyone tell me why we need this analog to digital and digital to analog conversion? Yeah, actually previous week I have explained that one also. Okay, so you know that in digital system, okay, so you know that digital system have some digital electronic system. Okay, digital electronic system have some advantage over analog system. Okay, so we like to process the data in digital domain. Okay, we like to process the data in digital domain. Okay, but you know that, okay, so we prefer digital domain. Digital domain, it is preferred because it is easy. Design and implementation is easy for digital system. So we like to process our data in digital domain. Okay, so you know that computer, our phone. Okay, yes, our phone, like that, all are digital domain equipment. Okay, their processing is in digital domain. Those are digital signal processing equipment. Okay, DSP equipment. Okay. So we like to digital processing, digital signal processing. Okay, but you know that real world is not digital. Okay, for example, if we consider a voice of someone, it is analog signal. You already know. If you talk to a microphone, if you talk to a microphone output will be an analog signal like this. Okay, analog signal. Okay, and if you consider a temperature varying the temperature during the day, it will be analog. No? You have a continuous varying. It is analog. So, and if you consider uh, anything, okay, pressure of water, it also analog. Okay. Now, if you consider height of a human, it is analog. Okay? And if you consider the picture, it is analog. And if you consider video, it is analog. Okay. So the real world is analog. Our world is analog. Okay. But we like to do digital processing. Okay. So what we have to do? we have to convert this analog domain into digital. Okay, so we have to use the ADC. Okay, and again, when you give the output, okay, the processing is okay. Okay, but then you have to again convert it to an analog. Okay, DAC, using the DAC. So the ADC and DAC are very important equipment. Okay, because if we like to do digital processing, but the real world is analog. So we have to do that conversion. Okay, digital to analog conversion and analog to digital conversion. Okay, okay. So that is the need for the ADC and DAC. Okay, so we will first discuss the ADC. Okay, ADC and DAC process. Okay, in previous week also we have discussed this up to some level. Okay, but I think some information are not necessary for this course. For example, Nyquist theorem is not. We no need to. You should know the Nyquist theorem. Okay, but for this course, maybe you will not ask the question. You will be not asked the question in Nyquist theorem part. Okay, so that is why I told you that for some informations are not needed for this course. Okay, but as an engineer, you should know everything. Okay, you should know the basics. Okay, otherwise you can't understand completely. But anyway, I will try to give you the very important details. Okay, so maybe you can remember the previous things you have learned. Okay, okay. So we will check the ADC process. Okay, analog to digital conversion process. Okay, this is also called as pulse code modulation. Okay, PCM. Okay, and we have three processes. We have three processes. Okay, we have three processes. The first one is sampling. The second one is quantizing. The third one is encoding. Okay. So we have three processes in ADC system. Okay. Okay. So I will explain it quickly. Okay. So you have analog signal like this. Okay. You have analog signal like this. Okay. First, you want to convert this. Okay. So this is analog signal or continuous time signal. Both are correct. Okay. Because I have already told you that analog signals are normally continuous time signal. Okay. Continuous time signal. Okay. So this is analog signal as well as continuous signal. Okay. Analog signal make a continuous time signal. Okay. Okay. So first we need to sample this signal. Sample means, okay, so you know that I have already told this one also in the previous week. Okay, normally we are talking about electronics, no, electronics and electrical. Okay, electronics and electrical. So we are dealing with voltage signal. We are dealing with voltage signal, and we are dealing with sometime current signal, not much, okay, and sometime power signal. But these two are very rare. We rarely use. Most probably we are dealing with the voltage signal. Okay. For example, okay, if you want to, so again you may have a problem. Okay, real world is not voltage, no. Real world is not a voltage on or current or power. Okay, real world may be the temperature, maybe a voice. Okay, voice. Okay, or maybe a height or something. Okay, so anyway, but you can't do this electronically process. Okay, this voice, temperature, these physical quantities you can't directly process in electronics domain. Okay, so first what you have to do, actually. Before converting uh, these, these to digital domain, first you have to do what? You have to convert these physical quantities into what? Into voltages or current. Voltage or current. No? Okay, so what is the equipment or component we use to do this? What is the name for that? Please tell me. I think you know the answer. Okay, you are mechatronics engineer, so you should know this. Okay. So mechatronics. So you are mechatronics engineering students now. So I think you have to learn thoroughly of this component also. What is this? If you want to convert a voice into voltage, you can use what? You can use a microphone actually. It convert voice into voltage or current signal. Okay. And if you want to find the temperature or measure the temperature and process it in electronically, or let's say that you want to process it means the historian is also processing. Okay. So uh, if you want to store a temperature in electronics equipment, what you have to do? You have to convert this temperature into a voltage or current. Okay. So that is called temperature sensor. Okay. Actually, these conversion device we called sensors. Okay. We are not talking about the sensor actually in this course. Okay. But the sensors are also very much important. Okay. And also this is called input transducer actually. Input transducer. Transducer. Okay. And again, you want to convert this voltage into a physical quantity. Okay. So that is also some kind of sensor. Okay. But that is called output transducer. Output transducer. Input transducer and output transducer. Input transducers are sensors. For example, let's say that you want to you want to send someone talking to the microphone. Okay, someone is talking. Okay, and you will get the analog signal here. Okay, so this microphone is the sensor. What is it doing? It convert voice into a voltage signal. Okay, voltage signal. Now you want to process this in digital. Okay, so then what you have to do? You have to send this analog signal through a ADC. Okay, ADC. Then you will get a digital signal like this. Okay. Then you process this. So then you process this. Okay, let's say that you have digitally send it to somewhere. Okay, then you need to have a DAC to convert this digital signal into analog again. Okay, so you can get the analog signal here like this. Okay, so here also the signal is analog and this is a digital signal, analog to digital conversion. This is digital to analog conversion. Okay, and then this analog signal you have to send it to a speaker. Okay, this should be a speaker. So this is microphone. It is the voice sensor or the input transducer, and this microphone is the output transducer. Okay, output transducer. Okay. But we are not. This is the sensors are also conversion device. Okay, the sensors are also signal conversion device. But in this session, in this lesson, we are not going to talk about this input and output transducers. Okay, and we are only dealing with ADC and DAC. Okay, but you should have this prior knowledge. Okay, then you can understand the situation very well. Okay. Okay. So I hope this is clear for you. I get the example. Okay. This is example. How the sensors, that means input transducer and output transducer and ADC and DAC are employed in a system. Okay. Is that clear? Okay. So we will come back to the our lesson. Okay. ADC. Okay. So now so we have analog signal. Okay, so this analog signal may be output of any input transducer. It may be output of input transducer, maybe a microphone, maybe a temperature sensor, maybe a fire sensor, we don't know. So we get any signal. Okay, maybe a pressure sensor. So also you have a analog signal. Okay, and this analog signal is a continuous time signal in nature. Okay, so normally it is a continuous time signal. Okay, and first step is sampling. So that one you have to get the sample. Okay, so this is a voltage. Let's say that this is a voltage signal. Okay. Okay, then you have to sample it. That means you are getting the sample of this signal. Okay, like this. Okay, you are getting a sample. Okay, you are getting a sample. And you know that this is the sampling time. This is the sampling time Ts, and sampling frequency is 1 by Ts. Okay. And this sampling frequency should be greater than or equal twice of this signal frequency. Okay. 2f. Okay, so this is the Nyquist theorem. We don't need these things. Okay. Okay. So so the sampling. Okay. So what you need to know here, first we are doing the sampling for the continuous time signal, then we can get some samples. Okay, we can get some samples of the voltage, maybe like this. Okay, maybe like this, we can get the sample. This is the sample. Okay, tell me, what is this signal type? Please answer that question. What is this signal type? This is a continuous time signal or analog signal. Then what is this signal? Please tell me. Someone? What is this signal? This is the continuous time signal or analog signal. And what is this? What is this signal? Yeah, thank you. It is a discrete time signal. Okay, it is a discrete time signal. So what is sampling doing? The first step is the sampling. And what is sampling doing? It converts continuous time signal into digital time signal. So that is the first step. Okay. Now, okay. Now what we do is actually, so here some voltage. No, here some voltage we have. Okay, we have some voltage here. Okay. Let's say that this is 2 volt, this is 3 volt, this is 5.2 volt, this is 3.1 volt, like this. Sorry, 6.1 volt, like this. These are voltage level. Okay. Now we have a value. We have a value. Okay. So you can convert this value into a binary number. Okay, you can convert this value into a binary number like 10, 10, 10, like this. Okay, and if you have this level also, you can convert into a binary value like this. Okay, so you can represent this voltage level using a binary value. Using a binary value, is that okay? So you can use a binary value to represent this analog value, analog voltage value. Okay, so it may be 2 volt, 3 volt, 2.5 volt, 8.1 volt, so on. Okay, so you can represent it using a digital using a binary value. Okay, But before uh, doing that, we have to quantize this signal. Okay, actually that is called encoding, assigning bits, okay, to that voltage value we called as encoding. Okay? But before that we need to do a quantize. Okay, so I have told you that try to understand why we need the quantizing. What is quantizing and why we need quantizing? So do you have that answer? I have told you previously, find what is quantizing, and why we need quantizing. Why we need quantizing. I just asked you to try to find this. Okay. I think surely you have learned this. Okay. In the signal and system, definitely you have learned this. Okay. But now you may be you may be not you may not remember it. Okay. That is okay. I just asked you to refer your old notes and try to remind this. Okay. So anyway, I will explain. Okay. So say that, okay. Say that we have a discrete signal like this. Okay. Discrete signal like this. Okay. Signal like this. Okay. Okay. Discrete signal like this. Okay. So we have some voltage values. Okay. We have some voltage value. Maybe 2 volt. Okay. I will take only the complete value. Okay. Without using decimal value, I will complete only. No, I will also consider the decimal value also. Let's say that 5.2. This is 6. This is 6.2. Likewise. Okay. So now you have some values. Okay. You have some values. Okay. Now you need to represent this one sample. You need to represent this one sample. Okay. You need to represent. You need to represent one sample from 4 bits. Let's say like this. Okay. So you are going to represent one sample using 4 bits. What is this one sample means? What is this? What are these? These are voltage values, no? Voltage values. These are voltage values. If we take voltage signal, if we take current signal, these are current values. Okay. But most probably we are dealing with the voltage signal. Okay. So this one sample means it is a voltage value. Okay. Now you want to represent that voltage value using 4 bits. Okay. Now tell me, okay. Now let's say that the signal is 6.2. Okay. And you have here you have, please try to understand this very well. Okay. So this is the basic. Okay. Let's say that this is 7 volt. Okay. So this is 2 volt, 5.2, 6.27. Now you are going to represent your this signal, this voltage level using 4 bits. Okay. So 4 bit means how many combination you have? How many combination you have? Combination you have. Tell me. If you have a 4 bits, how many combination you will have? Let's take 3 bits. Okay. Let's take 3 bits. Otherwise, it will be much complicated. Okay. So now you are going to represent your voltage value using 3 bits. Okay. Now tell me how many combination you can represent using 3 bits. That is very easy question. Please tell me. If you have 2 bits, okay, how many combination you, if you have 3 bits, how many combination you will have? discussion. How many combination you have for 3 bits? Bit means 1 or 0, no? You have here 1 or 0. Okay. So actually these are the levels. Tell me, please. How many combination you have for 3 bits? Please tell me. Yeah, thank you. Okay. So that is very easy question. Okay. So if you have 3 bits, it is 2 to the power 3 because this bit is 1 or 0. 2 levels are there. Okay. So 3 bits, it may be 2 to the power 3. Okay. So that is 8. You will have 8 combination. Okay. So if you consider 8 combination, one, it will be like this. Okay. I will write it here. Okay. Write it here. So it will be like this. I will write it here. 0, 1, 0, 1, 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this will be 0, 0, 1, 1, 0, 0, 1, 1. So this will be 0, 0, 0, 0, 1, 1, 1. Okay. So these are the combination. So these are the combination. Okay, now tell me, if you are going to represent your voltage level by 3 bits, that means how many voltage levels you can represent here? How many voltage level you can represent here? How many voltage level you can represent here? You have 8 combination, then how many voltage levels you can represent here? Only 8 voltage level, no? So this is your first voltage level, maybe this is the second, this is the third, fourth, fifth, seventh, eighth. So you can represent only 8 voltage levels. Is that clear? So here you have many voltage levels, no? But if you use 3 bits, you can represent only 8 voltage level. So what we have to do? We have to approximate these voltage level to 8 voltage levels. Okay. We have to approximate these. There are many voltage level. Okay. With many values. Okay. So we have to approximate up to 8 voltage levels. Okay. Did you get this point? Okay. So I will explain it. Okay. I will explain it. I think I have dropped for a while. Anyway, can you hear me now? Can you hear me?
Yes, sir.
Okay.
Yes,
So,
sir.
okay, thank you. Okay, so we have to approximate this voltage levels. Okay, we have to approximate. Okay, for example, we have, let's say that here you have 2 volt, 5.2, 6, 6.2, 7. Maybe some voltage value may be there. Okay. Okay. So let's say that Wait for a moment. Give me a 5 minutes, okay? Not 5 minutes. Give me a 2 minutes, okay? I am login using my phone, okay? When the calls are coming, the signal, the connection is dropped, okay? I can't, our campus network, we can't use, it is always dropping, okay? Give me a moment. Okay, okay, so now can you hear me? Can you hear me?
Sir.
Hello, can you hear me?
Yes, sir.
Okay. Now you can see that we can represent only 8 voltage level using 3 bits. Okay, but there can be many voltage levels. Okay, okay. So what you have to do, you have to approximate some values to 8 voltage levels. Okay. For example, okay, I will explain it using this example also. Okay, let's say that your signal is from 2 volt to maybe 8 volt. Okay, no, your signal from 0 volt, okay, 0 volt to 8 volt. Okay, so you have the voltage range between 0 and 8, correct? Okay, okay. So you can have many values like 0, you can have 0, okay, so you can have 1.1, 1.2, 1.3, or 1.215. Okay, like this you can have infinite number of levels. Okay, it is also countable with this 0 and 8. You may have infinite number of levels. Okay, but you can represent only this 8 and this 8 not equal. Okay, so I will take this 7. Okay, otherwise you will confuse this 8 and with this 8. Okay, so let's say that your voltage level, your signal voltage level is between 0 and 7 volt. Okay, 0 and 7. Okay, within this 0 and 7 you can get any voltage value, you can have any voltage value. Okay, voltage value. So that means you will have infinite number of voltage values. Okay, but you can represent only 8 voltages. So what you have to do? Okay, first you have to find what is the minimum voltage level you can represent. Okay, first this is 0 to 7. Okay, so first your voltage range is 0 to 7. First you need to know what is the minimum voltage level. you should represent. How you find this value? Can anyone tell me? So you have 8 combination. Okay, so you can have 8 different combination, and voltage level are 0 to 7. Okay, and if you want to find the minimum change of the voltage, how could you find it? You have to simply, okay, you have to simply get this range. Okay, so range is 7 volt minus 0. This is the range. Okay, this is the voltage range. Voltage range, and you have to divide the number of combination. Number of combination. Number of combination. Okay, so you have to divide it number of combination. So here you have to divide that with 8. Okay. So you have a voltage value. What is this value? Can anyone tell me? What is this value? 7 divided by 7 divided by 8. 0.875. Okay, 0.875. Okay, so you have a value 0.875. Okay. So what is this value? This is the voltage value per one combination. Okay, per combination. Voltage value for combination. So you have 8 voltage values. Okay. Then you can represent. Okay. Then you can so you have 8 voltage values. Okay. 8 voltage value. 1 voltage. You have 8 combination. Sorry, you have 8 combination. From one combination, you can represent this voltage value. What is that mean? Okay. So you can do it like this. Okay. So this you can, so your voltage is 0 to 8. Okay. So this, let's say that this is the last value, and this is the minimum value, and this is the highest value. Okay. So here it is the 0 volt, and this is the 8 volt. Okay. You can represent. Okay. So using this, 7 volt. Okay. 7 volt. This is the 0 volt, and this is the 7 volt. Okay. So now you can represent it using 8 combination. So between this, you have 8 combination. Okay. So this will represent 0.875. Okay. And what is the value for this one? What is the voltage value? This is 0 voltage, and this is 0.75 voltage. And what is this voltage value? You can use this combination to the next voltage value. So what is the next voltage value? So this is the minimum variation you can get. Then what is the next voltage value? What is the next voltage value? Please tell me. So what I am doing here is, you have 8 combination, no? So this is the, can you understand this? Okay, if you can't understand, please let me know, okay? Okay, so you have 8 combination, okay? So this is the first combination, this is the second, this is the third, this is the fourth, this is the fifth, this is the sixth, and this is the seventh, and this is the eighth. You have 8 combination, okay? So you have the voltage range between 0 and 7, okay? So this is the minimum level. I assign the 0 volt here, and this is the maximum level. I assign the 7 volt here, okay? And there are 5 levels also. So I can assign some voltage value to that 5 levels, okay? So what is the minimum voltage change? It will be 0.875, okay? So between this 2 combination, I will have 0.875 variation, okay? And between this one also, I will have the same variation. That means I can get twice 3.875, okay? So what is the value here? Let me know if you can. Okay, so what is the value here for this one? This is the first, this is the second, this is the third. Okay, this is 1.75. Thank you. Okay, and what is the value here? What is the value you can assign here? Please tell me, someone. So this one and this one, there should be 0.875 variation. So what is the value for this one? Yeah, it should be this one plus 0.875, you know. I will write it here, otherwise you can't. So you have this combination 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1. Okay, so you have 8 combination, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this this understanding is very important. Okay, actually, I could see that the student who are doing the final year project also doesn't have this sense. Okay, so they have to face a lot of problems when they are developing a system. Okay, so please try to understand this very well. So if you have any problem, please ask me. Okay, then I can explain it again. Okay, so there are 8 levels. Okay, so you are using 3 bits. Okay, and you can use only 8 levels. Okay, 8 voltage levels. Okay, now what is your voltage range? It is between 0 and 7. Okay, so what I am doing now, I assign 0 voltage for this one, 0 0 0 combination, and 7 voltage for the this combination, 1 1 1. Okay, now I need to find what are the voltage levels I am going to assign these levels. Okay, for that one, what I have to do is I get the full range, that is 7.0, 7 minus 0, and I divided it by number of combination. So I will get 0.75 voltage value. Okay, this voltage value I get. Okay, so now, okay, now you can see that this is the minimum voltage value I can represent using this level. Okay, not the minimum. This is the minimum voltage changes. This is the minimum voltage change I can use for this to represent this voltage range, 0 to 7 range. Okay, so this is the more minimum voltage change. Okay, then 0 to this level, I can have this voltage range minimum. Okay, then from this one to this level, I will have another. Okay, so when it come to here, I can just add another 0.785. So it will be 2 by 2 into 0.785, and one student say that it is 175. Okay, and what is this value? For this value, again, you have plus 0.875. And what is the value here? Someone has, yeah, it is 2.625. 2.625. Then what is the value here? Tell me. It is 3.5. Thank you. It is 3.5. So you can see that this is the middle point. No? This is the middle point, and at the middle point, you can get the middle 3.5 voltage. Okay. And what is the value here? Please let me know what is the value here. Thank you. 4.37. This is 4.37 volt. This is 5.2. What happened? This another point should be there, no? So this is 0. This is 0. 1, 2. Check 0 to 7. Okay, 7 to 0. So I get 7 minus 0. So this is the value. Yeah, yeah. So I can't represent the 0 actually. Okay, I'm sorry. I can't represent the 0. Okay. So actually, because 0, so this is the minimum voltage range. This is the minimum voltage change. No. Okay. So this is the minimum voltage change I can represent. Okay. So here, instead of 0, you have to represent 0.785. Okay. So this 0, 0, 0, you can, for this 0, 0, 0, you have to, for this 0.875 voltage, okay, you can represent as 0, 0, 0. Okay. Likewise. Okay. So it is going likewise. Then this will be the 1.75. Okay. This will be the 1.75. Okay. This will be the 1.75. And this will be the 2.625. And this will be the 3.5. Okay. And this will be the 4. Is that value? 4.37. 37 voltage and 5.25. Other one is the 5.25 voltage. Okay. So these are not correct. Okay. Another is the 6.126. 6.126. Okay. 6.126. Okay. And the final one is the 7 volt. Okay. So these are the voltage level you can represent. You can't represent the 0 voltage. Okay. You can't represent the 0 voltage because the minimum voltage change you can represent is 0.75 volt. Okay. So you can't represent all the 0 voltage you can't represent. Okay. So these are the voltage value you can represent. Okay, these are the voltage value you can represent. Okay, so you have voltage value 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you will have 8 voltages well. 8 voltages well. Okay, now what is so I think now you can understand why we need the quantizing. Quantizing is the approximate to the 8 voltage level. Okay, so if you have any voltage level, you have to approximate it to this voltage levels. Okay, it to this voltage level. Otherwise, you can't represent that value. For example, if you have 0 volt here, if you have 0 volt here, you have to quantize it or approximate it to this voltage level, 0.875. Okay, and if you have 2 volt here, if you have 2 volt, okay, here you have 2 volt. So what is the value you have quantized this 2 volt? What is the value you have quantized this 2 volt? Tell me someone. So you have 8 voltage level. Okay, and if you have 0, you have to you have to quantize it to 0.175. So this is the minimum voltage level we can represent because, okay. And if you have 2 volt, what is the voltage value we have to quantize? Please tell me. So what is the, so you have to approximate. So you have to approximate this 2 volt in any voltage level. The approximator to the most approximation value for these levels. Okay. So what is the value? If you assign this value, if you assign this 2 volt, approximate this 2 volt to what value? These are the voltage value you can represent. These are the voltage value you can represent. Okay. And you have 2 volt. So what is the value you have to approximate this? So quantize this 2 volt. Very easy. I think you can answer that one. These are the voltage level. You have to quantize it to 1.75 because this is the most approximation 1 to 2 volt. Okay. So 2 volt, you will have to quantize from 1.75. Tell me if you have 3 volt, 3.1 volt, what is the value you are going to quantize it? If you have 3.1, what is the value you are going to you have to quantize it to this one or this one. So if you convince it to this one, this is 3.1, no? 0.4 variation is there. Okay. And here it is 0.5 variation. Okay. So you can quantize it to this one. 3.1 volt, you can quantize it to 3.5 volt. Okay. And if you have 4 point, let's say that you have, I will write here. Okay. So you have 0 value, you have to quantize it to. Okay. So these are the actual voltage value. These are the quantized voltage value. Okay. These are the signal voltage value. The discrete time signal have some voltage value. Okay. So these are the signals. Okay. So you have 2 volt. Okay. And you have 3.1. Let's say that you have 3.6, 4, okay, 4.8, 5.9, like this. So these are the values you will have. Okay. So what are the quantized voltage level you can get? Okay. So these are the quantized voltage level. Quantized voltage level. Okay. Quantizing means you have to approximate this voltage, this available voltage to any voltage value here. That is the quantizing. So you are going to approximate it to the representable voltage value. Okay. I think the word is encodable. Encodable. Okay. Maybe this word is not correct. Okay. So in quantizing, what you are doing? In quantizing, you are approximate any voltage level in the discrete time signal. Okay. So after the sampling, we will have the discrete time signal. Okay. So you are going to approximate any voltage level in the discrete time signal to a encodable voltage level. So that is quantizing actually. That is quantizing. So this may be not the definition. Okay. So you can find the definition in maybe in the Wikipedia or something. But this is the explanation. Okay. So if you quantize this voltage level, can you tell me what are the voltage levels you can encode this? Okay. So try to find, at least try to tell me this one, this one, this one, and this one, 4 voltage levels. Okay. Please tell me.